All right, hey, how's it going, guys? Mr. Fortin here, and so I'm gonna go through with you a bunch of problems actually that are in your homework due Wednesday. It's Monday right now, so you got a couple days to do this. Now, I know that some of you might be thinking, "Oh, I'll get to this Google Classroom, look at it, and you're like, whoa, that's a lot of problems. Is he really expecting me to do that many? It's not gonna take forever, right? I did the self test on Monday, and that felt like that took a long time. So, anyways, if you're in that boat, perhaps you're not quite there yet when it comes to the shortcuts that we've been trying to show you on Friday and Monday. And that's okay. This sometimes takes time. If you watch the video on Friday, I talked about how, especially the 30, 60, 90 shortcut, even when I was restudying to become a geometry teacher, just for some reason, I was like, I'm really having trouble seeing it. I'm having trouble putting this shortcut to practice right now. So that being said, if the shortcut came to you quickly and easily, going through this problem set isn't too crazy. I know it's Monday at 4 p.m. I already have a handful of people who've already turned it in, really eager beavers there. But you might be an eager beaver too, but just need a little bit more guidance and really like, well, I want to use Pythagorean theorem on all of these. Oh my God, how am I ever going to do that many of them? So let me show you exactly how this problem set's kind of intended to be answered, because a lot of these questions should come fairly easily. For instance, x is 6 root 2 in this one. How long did that take me? 2 seconds, right? 2 seconds. Why? This is a 45, 45, 90 degree right triangle. The hypotenuse is always root 2 times as long as the leg. I won't write that out. We wrote that out the other day in Friday's video lesson, which was the half hour we spent here. We're not doing that right now, okay? We wrote how the hypotenuse relates to the leg, okay? So you got to know that. We also need to know this was how the leg relates to the hypotenuse. We also need to know how the hypotenuse relates to the leg of a 45, 45, 90. And I had you put that in your notes, had you write it down, like write it down, like go back, rewatch that video. If you're having trouble with that, then you didn't watch the video. You didn't put it in your notes. You're not sticking to it, which is that the hypotenuse is root 2 times longer than the leg. So that means this has got to be 10 root 2 divided by root 2 to get to the leg. So to go from hypotenuse to leg, you simply divide by root 2. And if you have the right root 2 right there, x just equals 10. X just equals 10, and we're good to go. We have our first two answers. Third one here, again, harder is when you have the hypotenuse. How do you get the leg? And this is tough here because this isn't 12 root 2. If this were 12 root 2, that would just be 12, because whatever this is root 2 times longer than that. So here you might have to do it a long way, or you could look for a shortcut, or you can get a shortcut that maybe I suggested to you on Friday's video about how one of the legs, maybe you put in your notes, maybe check out your notes here. How do one of the legs relate to the hypotenuse of a 45, 45, 90 degree right triangle? And maybe we can write that down. We wrote that down for 30, 60, 90s. But anyways, let's check it out here, because I think it'd be a good summary statement for you to put down here. Maybe we'll put it on top here. Okay, so first of all, just two things here. Maybe because we didn't put this in our notes. When I think of it, 45, 45, 90. The hypotenuse is root 2 times the leg. Okay, so that was easy here. We just multiplied by root 2. And then the leg is, well, we divide by root 2. Okay, divide by root 2. So is, right, divided by root 2 as long as the hypotenuse. And the way this looks out here, I'm going to give you a little bit more of a shortcut a little bit later, but maybe we'll try to do that here too. If this is x, then this is, right, x times root 2 is 12. So that means that this has to be 12 divided by root 2. Okay, we think opposite, right? What do you have to do? We take the 12, we got to divide by root 2 in order to get down to whatever this is here, okay? The problem with this is that now you have an irrational denominator, okay, an irrational denominator. So you got to do that thing that we were doing since the beginning, which is we want to write it this way. We want to have a rational denominator, so we're writing it the same way. You get to understand what 2 root 2 means, 3 root 2 means. You don't understand what 12 over root 2, right? That's not worth your time here. So we want to quickly rationalize this here. 12 times by root 2 is 12 root 2, and then that's over 2, and already we're getting messy. If I have 12 root 2s, okay, so the whole thing, the number in front, you kind of think of as like a coefficient, and root 2 you can kind of treat like a variable, right? Like 5x or 12x. Think about this as like 12x divided by root 2. 12x divided by root 2. If I have 12 of something, right? 12, and we'll call that something x, right? 12x, and I split it 2 ways, how many x's do each person get, right? Remember, x is just a generic variable to fill in, right? 12x's I split it 2 ways. Each person's going to get 6x, right? 6x here. Much like if I have 12 root 2s and I split those root 2's to 2 people, how many root 2's does each one get? Each one gets 6 root 2. Okay, 6 root 2. So that is our answer for this one, 6 root 2. But I want you to get there even quicker if possible. You could just do this. Take the hypotenuse, right? Leg is divided by root 2 as long as the hypotenuse. And think about this, 6 root 2, how does that actually compare? And I will erase all this and maybe just move up my answer that I have here and move it a little bit closer. This is x is going to equal 6 root 2. Well, check this out, because you can actually, a lot of people use shortcuts for this one too. This 45, 45, 90 degree right triangle. 6 root 2 is right here. How does it relate to the 12? Well, 6 root 2 times by root 2 would be 12, right? It would be 12 here. You can double check your answers right here, okay? Because 6 root 2, we know if we multiply by root 2, we get the hypotenuse, right? The hypotenuse is root 2 times longer than the leg. Root 2 times root 2 is what? Well, it's 2. And 6 times 2 equals what? It's 12, right? That's how the 12 thing gets there. So we can check our answer, make sure we got it right. So anyways, another summary statement you might put down for 45, 45, 90 degree triangles is that the leg is, sure, it's divided by root 2 as long as the hypotenuse. But we could say, right, look at how the numbers relate here. If we divide that number 12 by 2, we get 6. If we tack a root 2 on it, we're going to get there, okay? So the leg is, or what we can do instead is divide by 2 and then times by root 2 as long as hypotenuse. It's kind of confusing, right? But you want to get there so you can hopefully do these kind of quickly, right? Quickly. That's a goal here. So you can save your brain space for other stuff. You get to shortcuts here. And it works out. It turns out that works out. If I divide 12 by 2, I get 6. Tack a root 2 on there. I'm only times root 2 away from getting it back to the 12 here. So dividing by root 2 and timesing by root 2 puts you just multiply by root 2 away from undoing that whole division of root 2. Think about it. There's a lot of layers there. So maybe we'll just hopefully accept that. That's my shortcut that I could potentially use. All right. But yeah, you know, you do you, right? You try to do it quickly as well here. All right. I won't write the 30, 60, 90 degree shortcuts down here because those are some of your summary statements that were on your Friday homework that you put at the very end here. Hypotenuse, exactly twice as long as the shorter leg. So if this is 5, that's 10. Boom, we got an answer there. How about this one? Well, this is half as long as the hypotenuse because it's opposite the 30 degree angle. That's the thing you gotta notice here, right? This is the shorter leg, right? Shorter leg. We know it's the shorter leg here because, hey, I can draw in an equilateral triangle if we have that there. So my equilateral triangle is more like this right here. Okay, so this is the shorter leg, but it's also opposite the 30 degree angle. Okay, look, our 30 degree angle is here. It's opposite the length 5, so that's going to be shorter leg. 60 degree angle is going to be opposite the longer leg, right? Remember, the larger the angle of the triangle, it's going to be opposite the larger the side. Okay, so if this is 60 degrees, this is a longer side. It's x root 3. Okay, but this here, x is half as long as the hypotenuse, right? This is why we had those summary statements the other day, right? We wanted to write down the shorter leg is half as long as the hypotenuse, and it's also root 3 divided by root 3 as much as the longer leg, right? It's tricky, right? It's tricky. Always go to the shorter leg first. That's my hint. Detour through the shorter leg. This one here, we have both legs on this one. We know the shorter leg. That's nice. This is just going to be 3 root 3. This is going to be 3 root 3 because the longer leg is root 3 times by the shorter leg here. Okay, so this is just puzzles, making it fit, baby. Making it fit. We got this. Ooh, this must be 45, 45, 90. Why? How do I know that? Well, this looks like a rhombus whose diagonal is being drawn. It's a rhombus. So I have x here, x here, x here, x here. So it's a rhombus. That means my diagonal bisects both of the angles. What are these angles? Those are all 90 degree angles. Okay. No, it's a square because I have a 90 degree angle here. And if you have a parallelogram with one right angle, then it's a rectangle, right? That's actually a theorem. It was a corollary. I think it was a theorem that we had in one section. So if it's a rectangle and then all equal sides, it's got to be a square. So anyways, 45, 45, 90. So here, A is my hypotenuse. So let's test it out here. 4 root 2. Did you get that? Well, it's the answer. That's the answer. Sure, you could have done it the long way. That's fine for now. I think it's appropriate for now. I think if I were at your stage, I would do that too. I would do 8 divided by root 2, rationalize the denominator. Okay, do root 2 over root 2. And then you get 8 root 2 over 2. Okay, and that would equal 4 root 2. Because if I have 8 root 2s, I'm splitting them 2 ways. Each person's going to get 4 root 2. Okay, or you can think, you can kind of work backward that whatever I have here, if I multiply it by root 2, I get 8. And that would be true here because 4 times by 2 is 8. And 4 times by root 2 times root 2, right? Root 2 times root 2 would just bring it back to 2 and get to 8. Anyways, I'll just keep doing examples, keep doing examples, keep doing examples, and keep finding your way. finding your way here. Hopefully you're doing it my way. If not, you're developing your own way. You're talking with your group. Talking with your group or talking with somebody you do geometry with. Because, man, these puzzles get a little tricky here and there. All right, this one here looks like we have an equilateral triangle because this is 20. Okay, what do we know about equilateral triangles? Well, they're going to create 60-degree angle here. An equilateral triangle is a median to the base, to one of the bases of an equilateral triangle. So it's gonna, the median is also gonna be the perpendicular bisector of the side of an equilateral triangle or an isosceles triangle. So anyways, this is 30 here. So we have another 30, 60, 90-degree triangle. So this is 10, so x is 10 root 3. All right, you see how this can be done kind of quickly? I think I said budget about 15 minutes for these classroom exercises. But if you get super caught up on one, you got to move on. You got to move on, okay? Because these are some quick hitters here. That's why I'm doing the quick hitters with you right now. Okay, this is 9 root 3. My advice here, always go to the shorter leg first. Always, okay? So I'll write that down, okay? Write that down in a different color. Detour to shorter leg, right? You see how in this one here, they give us 9 root 3. You're going to want to figure out what that hypotenuse is because this is a hypotenuse of this other triangle, okay? But it's very hard. It's very hard to go through the longer leg to the hypotenuse. So my recommendation is figure out what the shorter leg is and then just multiply it by 2 to get the hypotenuse. Because remember, the shorter leg of a 30, 60, 90 is just half of its hypotenuse here, okay? So if this is 9 root 3, the easier thing is to realize that this longer leg is root 3 times longer, whatever the shorter leg is here. So this is 9. To get to the hypotenuse, I just got to double it, okay? This is 18 right here. So that means that x has got to equal 9 root 2, okay? Because I multiply this by root 2, I would get 2 times 9, and that's 18. Going real fast for you. That's right. Rewatch the video. You can watch it a second time. I don't need to keep you here for days if you feel like you just need a quick video for this. Regular hexagon. Ooh, A, B, C, D, E, F. AB equals 8. Okay, that's the side length here. This is 8 right here. Find AC and AD. Well, it looks like this is an isosceles triangle, so there's that. I haven't done this problem in a while. AD, let's draw this one. Interesting, okay? This is 8 here, and I noticed something. Okay, I might have to zoom in a little bit here to really get granular with it. We call this granular. And I'll get a very small thing here, okay? First of all, we know isosceles, like regular hexagons, so we know that regular hexagons have 120-degree angles here. How did I get that? Well, we got to remember the formula, the quantity n minus 2, right? We can actually create 4 triangles. So look, 1, 2, 3, 4. 4 triangles out of a hexagon. So n minus 2 would be 4 times by 180. There's 180 degrees in all 4 of these triangles. So that would equal 700 and, 4 times 180. Yeah, 720. Okay, that means that each of these angles is 120 degrees. Okay, that's the one interior angle measurement of a regular hexagon. So that's 120 degrees right there. This is an isosceles triangle. Okay, so that means whatever remains out of 180, these are going to be congruent down here because it's an isosceles triangle. So using the ITT, we know that angle BAC and angle BCA are congruent to one another, and we only have 60 degrees to work with here. So this is 30 degrees here. This is 30 degrees here, okay? And this, look at this here. This is 30. What we know about angle BCD is one of the interior angles of the hexagon, the regular hexagon. So that's the same as like this angle here, and that's 120 degrees again. So 30 plus whatever this is 120 degrees. That's 90 degrees right there. Okay, so we have a right triangle. This is where we're finding our right triangle. This is 30 degrees. Look, this bisects the whole thing. This bisects the 120. So this is going to be 60 degrees here, so this also has to be 30 right here. A lot of moving parts, man. A lot of moving parts in this stuff. Okay, and this bisects the 120-degree angle we have here, so this is 60. What do we notice? Yes! Success. We end up with a pretty freaking sweet 30, 60, 90-degree triangle. Wow, magic. Magic, yes. Okay, but this shorter leg is 8. Okay, so that means, well, we're asking us to find what freaking AC is right here. AC is the longer leg. That's nice. We have the shorter leg. The shorter leg is 8. Longer leg is 8 root 3. And AD, which is the hypotenuse of this 30, 60, 90, is 16. Huzzah, right? Sweet. You feel good when you get a problem like that. Even Mr. Foreign's like, where's this going to go? Ooh, this is going to get tricky. So that's what it's all about. Again, getting pushed into that place of discomfort, right? Human beings don't often want to be uncomfortable, but when we get pushed there, right, we find a way to acclimate. If you have had trouble acclimating this year, I'm going to keep working on it, right? Because I want to see you acclimate. I want to see you persevere, right? Persevere here, okay? And there's where we got it. Rewatch the video, right? Watch it again. Try something different, right? What helped me there? I sketched it out. I didn't know the answer off the top of my head, right? I know that. I sketched it out. I tried some different things. I found a triangle we've been studying recently. Express PQ, PS, and QR in terms of A. So let's check it out here. We got A here. Oh, this is easy enough. You know, sometimes I look at these problems and I don't know how hard they're going to be when I assign them to you, because, you know, I can't sit here and do problems all day. Like, that's your job. But anyways, we have here A, and then we want to get PQ. Well, this is 30, 60, 90. Freaking 30. This is the smaller leg here. It's opposite the 30-degree angle. So this is going to be 2A. I like the size of this pen better. This is nicer. That's 2A. Okay, PQ equals 2A. PS, okay, we can get that. Actually, that's very easily here because this is going to be the longer leg of 30, 60, 90. That's going to be A root 3, okay, because you take that, you tack on a root, multiply it by root 3, and that's what you're going to get for the longer leg of 30, 60, 90. And finally, QR, okay, QR is the hypotenuse. Oh, simple problem, A root 2. Multiply whatever this is by root 2, you get the hypotenuse. Look, this is longer, right? Clearly longer, this hypotenuse, than that leg or that leg, right? Those are the same things, that isosceles right triangle. So anyways, right, there's A root 2. A root 3 is about 1.7, so about 1 point. This is about 1.7 longer than that. Yeah, I'll buy that, right? Maybe the little things you're telling yourself in the head. Did I set this up correctly? This makes sense. Does my answer make sense here? Okay, so there's A root 2. There we go. I don't know how long I've been going for. I might check just to make sure this is of a reasonable length here. Oh, little algebra 1. Yeah, check it out. Fact form, quadratics. Okay, go about 16 minutes. There we go. I've been taking my time, but remember, I told you that the classroom exercises said, hey, spend 15 minutes on those over the next 2 days, right? I think you'll get a lot of them here, okay? Next up, I said written exercises. I don't have to do all of them, so hopefully I can get this done in the next 10 minutes. But just get zipping through them with you guys here. Guys, you got to do a lot, right? But stay focused. You're not talking as much, right? Because you're not like me. I talk a lot. So maybe you're watching this video, or you're gonna just watch it for me on Monday, and then get it done, and then do the rest later on Tuesday. That might be a good way to break up your work, and then keep pace and wrap up this section here on Wednesday. Okay, it says here, draw an equilateral triangle with a side length size 10 units long. Let's do it. Sketch it out. You don't have to do it perfectly, so just try to eyeball it. Boom, boom, and boom. Okay, we got here 10. And I didn't draw it perfectly. Like, this is definitely shorter, but oh well. Where are we going with this one here? Draw an altitude. Okay, I'm drawing altitude. Boom. So the altitude should create two congruent triangles, right? We would know that these are congruent because their hypotenuses are the same, and then this is congruent to itself, right? So this angle is congruent to that angle by, this triangle is congruent to that triangle by HL, right? We got congruent hypotenuses, the legs are the same, it's a right triangle, so that's HL theorem. So anyways, we draw in the altitude. It says on your diagram. So this is actually kind of similar to this, so maybe I shouldn't have assigned this one to you because we did this already. We actually did this, thought through it on Friday. It says on your diagram, show the length of each segment of the base. Okay, so here's the segment of the base of this equilateral triangle. We're thinking of it as base because we're going to treat this as kind of the vertex angle. So we draw it in here. So each segment, 5, this is what I'm looking for. I'm looking for a 5 over there for that. So we check that off the list. Use theorem 6-7 to find the length of the altitude. So I'm guessing that's the new theorem. Theorem 6-7 is the one related to, well, what kind of a triangle is this? If it's equilateral, this is 60 degrees. Okay, we have 90 degrees there. That means this has to be 30 degrees, right? It's just a reiteration of like what you've done on Friday, right? What you should have noticed here. Just make sure, did I get this, right? Did I get this? Okay, length of the altitude. Okay, well, this is 30, 60, 90. This is the smaller leg. Altitude's got to be 5 root 3. Part B, it says ask, like, just it's similar to what I had you do on Friday's classwork, which was like, it said use the Pythagorean theorem later to make sure you understand where this come from. To find the Pythagorean theorem to use the length of the altitude. Okay, so they sort of gave us that this is 5, or we deduced that because the whole side here is 10, and they asked for each segment of that hypotenuse. They're both 5. So 5 squared plus, I'll do A for the altitude. We'll call this the altitude. Okay, so I want to prove that it's actually 5 root 3 using the Pythagorean theorem, and I think we will because I think we did something similar to this in Friday's classwork. Okay, 5 squared is 25 plus A squared equals 10 squared is 100. Okay, subtract 25 from both sides. I get A squared equals 75. That's nice. So I got to think about perfect squares that go into 75. 1 goes into it 75 times. That doesn't help us. 4 goes into it. Well, it doesn't go into it at all. 9 doesn't go into 75. 16 doesn't go into 75. 25, does that go into 75? Yeah, it does. 25 goes into 75 3 times. So A squared equals, well, let's take a square root actually. Take the square root of both sides. And We'll get rid of this here because we'll evaluate the square root. Take the square root of a, undoes the squaring, so it's just equal to a. Square root of 75, well, that would be equal to the square root. Another way we can write 75, we can change our radicands here to 3 times by 25. And the square root of 25 is what? 5, because 5 times 5 is 25. So here I got 5 root 3 through another method, just again proving us, just as like a quick sanity check, that theorem that we talked about on Monday's lesson and Friday's lesson, it works, right? The longer leg of a 30, 60, 90 degree right triangle is root 3 as long as the root 3 times longer than the shorter leg, okay? And then compared to the hypotenuse, it's half as long times root 3, right? It's kind of awkward. So that's why I always go to the shorter leg. Detour through the shorter leg. All right, copy and complete the tables. A here, so this is easy, right? This is a 45, 45, 90. So you're just cranking through this stuff, man. I just like, it's not too bad, right? Not too bad. You need a little help from Mr. Fortin here, too, to kind of jam through it with you. But I hope you're able to do it, too. And, man, some of you guys' heads will be spinning. Like, so much, man, so much. But just do it. I mean, you're going to get tired before you get to the harder stuff, it seems like. It's a bummer. 4 over 5 root 2. Let's see what we got here. Root 5 is what? A leg. The other leg's root 5. Times by root 5 is 5. There we go. 6 is what? A. Well, this is 8 root 2, so we're going A, 8. There we go. Keep moving. Man, you guys are fall asleep before we get to the good stuff, which is later in the problem set. Oh, man. But, hey, this is the important practice here. 6, okay? There's my shortcut. There it is. That's it. 3 root 2 times by root 2 would bring you back to 6, right? Because root 2 times root 2 is 2. 2 times 3 is 6. Little shortcut for you here. And then if this is root 22, is the last one, I'll label it up. Well, what times root 22 is root 22? Well, that would be root 11, okay? You can multiply square roots like that's the only way you can multiply square roots is that if they're both square roots, right? That's the only way that we can actually combine. We can basically treat square roots as kind of like terms, right? Like terms. These are like terms right here. So we're gonna get 11 times 11 is 22. So anyways, my whole point of that is that they're both root 11, right? Root 11 squared equals 11 plus root 11 squared equals 11. So that would equal root 22 squared, which is 22. So we're working the Pythagorean theorem. It works based on the patterns we're showing. So they're both root 11. Okay, so it's to kind of second guess like that you're getting the root stuff correctly here. And hey, I think we're doing great on time. Let's go ahead and keep doing it right here. Number 9, D is 7. So that means that F is 14 and E is 7 root 3. Okay, because again, this is the short leg. Get used to it. It's right next to the 60 degrees. It's opposite the 30-degree angle. Okay, another way to help you on problems like this, sketch in the equilateral triangle. Okay, that's going to remind you, this is your shorter leg. This is your longer leg, the altitude of the equilateral triangle, and then the hypotenuse is just one of the sides of the equilateral triangle. So, hey, D to F, we'll double it. D to F, let's double it too. We get 2/5 here. D to E, we got to multiply it by root 3. All right, this one here, we got a root 3 in it. Nice, it applies to E, which is nice here. So E, always detour, right? Detour to shorter leg. What I mean by that is if you have a longer leg, go to the shorter leg first. If you have a hypotenuse, go to the shorter leg first because it's really easy to understand how the shorter leg relates to the longer leg and relates to the hypotenuse. Going directly to the hypotenuse in the longer leg, kind of confusing. I'll show you that here. This is 5 root 3. How do I detour to the shorter leg? Well, I just divide by root 3. There's 5. How do I get to the hypotenuse? Well, I just double the 5. I get 10. Right? You'd have trouble. Like, honestly, just be honest with yourselves. You'd have trouble with the longer leg going to 10 here. That'd be kind of tricky. You'd have to divide by the root 3 and then multiply by 2. Right? You have to remember that. But it's one step, right? You detour to the shorter leg, gets the longer leg after that. All right, E is 6. Okay, so that's a little bit harder, right? Because we need to detour to the shorter leg, and what we're going to need to do is 6, and we're going to divide by root 3, and we'll see if there's a shortcut here. Maybe we'll do it, and maybe we can talk about maybe there's a shortcut on this one that we're not really considering here. So I get 6 root 3 over 3. Well, I got 6 root 3s, and I want to split those root 3s 3 ways. How many root 3s am I getting out to my 3 people? Well, I have 6 root 3s, pass that out 3 different ways. 2 root 3, right? 2 root 3, okay? So then I get 2 root 3. So kind of similar to the other shortcut that I'm trying to get you guys to do with the leg of the hypotenuse. Sorry, the leg of the 45, 45, 90 is just we got to multiply it by root 2 to get to the hypotenuse. Here you can kind of think about, well, this is 6. What do I need to multiply to by root 3 to get to 6. Well, 2 times by 3 gets us to 6. So that means 2 root 3 has got to be here. Like, my answer makes sense, right? Maybe it makes sense to do out the work like this and then ask, well, if I multiply this by root 3, what do I get? I get the longer leg. So it works, right? It works here. Okay. Anyways, we got 2 root 3s. So if I got 2 root 3s and we have that for one person, but I want both people to have 2 root 3s, how many root 3s is the other person going to get? They're going to get 2 of them as well. So we'd have 4 root 3s entirely here. Okay. So a little bit tricky with the root 3 there, but the double 2 root 3, I got 2 root 3s right now. I'm going to multiply it by 2 because remember, f equals 2 times by d, whatever d is here, right? Because these are the same thing, right? These are the same things. It comes from equilateral triangle. So I take 2 root 3, double it, I get 4 root 3. And my answer is correct there. 13, what do we got here? 12 is the hypotenuse. Okay, that's easy. Detour to the shortest leg, okay? 12 is the hypotenuse, shortest leg 6. E is going to be 6 root 3, okay? 14, we're jamming. Guys, jam away. And you're getting done with your light part of your workout right now. You got some harder stuff later. Oh, man, this is a long problem set. 2 days to do it, though. Come on, you can do it. Persevere. Some people are already done, too. And it's like, it's not all like they're like, everybody's getting it right away type of folks. Some people who tried really hard today, too. Who I'm sure tried really hard and just wanted to get ahead of it so that they can think about it, I think, for a couple days here. All right, 14. Hey, we got the hypotenuse. That's nice, too. It's really just a longer leg. It's just, a pain in the butt. Okay, so this is 5 over 2, right? Maybe say 2.5 if you want to. So this is going to be 5 root 3 divided by 2. Okay, that's my video. So, hey, I figured I'd film that just to show you guys. Part of the emphasis of this is using shortcuts to your advantage. Hopefully you picked up a thing or two. Hopefully you get the swing of things here. I know it's kind of a lot of problems, but hey, again, I hope to push you a bit into that zone of discomfort to see how you acclimate, see how you persevere, and start thinking about those skills. When still, it doesn't really matter too much if you don't really get this stuff super well or not at all, because you'll want to get other things in your life in the future that are kind of hard. Thanks for watching, and message me if you have any questions. Hopefully you have a nice Monday and Tuesday. Take care. Bye.